The next speaker is actually two speakers. It's a shared session between Alex Naskos and Auguste Rame. Auguste is a full-stack developer, but like many others, decided to cheat a bit by using JavaScript also for the backend. And Alex Naskos is from Greece, but grew tired of the good Mediterranean life, so he wants to move to London to enjoy the extra COVID, the bad weather, and the British food. The talk is ZLS, a Zig language server. Alex, Auguste, the stream is yours.
Hello, fellow Ziguanas. I'm Auguste, and I'm here with Alex. And as Laura said, we're talking about the Zig language server. So I guess we can go to the next slide now. So firstly, why ZLS? Why did I make ZLS? Why does it exist in the first place? And the answer is, I began programming in Zig, and like many people, the Zig documentation isn't very stellar, right? That's why I thought about it. It's not very complete either. And I was wondering if, Zig already had IDE features such as auto-completion that could help me out. And after some research, there were a few LSP implementations. So I downloaded a few of them and tried them out, and they didn't really suit my needs. So I made my own.
So before we talk about ZLS in depth, I'd like to just talk a bit about the language server protocol, or LSP for short. LSP was motivated by a problem that has existed in the programming space for quite a few decades, and that is that not everyone uses Vim as a text editor, as they probably should. But people actually have preferences, so every text editor defines its own interface to extend its capabilities and add language features. This obviously can lead to some friction, as some extensions may be very good for some languages in specific text editors, while for other languages, the extensions may be subpar or not implement all the same capabilities. So people have to adapt their workflows to that. LSP was created exactly to address this problem. It is made by Microsoft originally for Visual Studio Code. It's a very simple protocol that can communicate over the standard input and output or TCP/IP. And it defines a few dozen requests and responses over JSON remote procedure calls, as well as a way for both client text editors and language servers to actually tell each other what they support, so that the user experience can be seamless. For example, a server may tell the text editor that it does not support the go-to-definition function. So the editor can adapt and try to use an alternative strategy to find the definitions, or simply not display the option in the contextual menus at all. LSP at this point is supported by most editors. This is just a list of some pretty popular editors. And you can find a lot of servers for mostly every language. On this URL, you can see a table with all details about what every editor supports, etc. So ZLS is a subset of, implements a subset of the latest LSP protocol. Obviously, it is written in Zig. Our main objective is to keep it as lightweight and efficient as possible. I'm sure a lot of people have used language servers which are not that good. I myself have used the Microsoft's Python language server, which can use up to half a gigabyte of RAM just for a handful of files without really any reason to do so. So this is a main priority for us, to keep it as small as possible so that you can run it anywhere without worrying about it. And of course, we want to support most Zig code. At this point, I have to make it clear that ZLS will probably never support 100% of valid Zig code. And this is mostly due to the advanced compile time evaluation capabilities of Zig. While these features are probably my favorite features of the language. They make analysis of source code quite difficult. We would probably have to re-implement the whole Zig compiler to actually get it to get ZLS to accept any valid Zig code, and obviously this is not in scope. But we do want to support a vast majority of code, of course, including everything in the standard library, as well as most user code, as long as you are not doing anything way too fancy in your compile time evaluation. Also, ZLS is obviously quite new, and sometimes it can crash or use a lot of resources, especially when opening huge files. So this is just a heads up. This is a very basic overview of what we keep in memory while actually running. I won't go into much detail, but it's just to show you that we have no overhead. We keep exactly the information that we need to execute the completions and all the requests that the client may want to. So at this point, I will switch over to an instance of Visual Studio Code so we can see ZLS in action. So this is a very simple file I created for this demonstration. As you can see, ZLS is already running. Here we can see the symbol, the current symbol we are in. And we have an outline of all symbols defined. First, I want to show some of the language features that are supported. And let's start with array list completions. Of course, array list is a type I'm sure everyone loves and uses a lot. So it's quite important to get it right, and it's not as easy as you may think. There's actually quite a lot of magic going on behind the scenes. So of course, we can just hover and we get a signature as well as the documentation comments. Here we can see in the init function that the library authors have told us that we need to deinit the array list so we can free the memory. So we will go ahead and add a call. As you can see, everything completes fine. We can access the fields and all the functions. So we will just call the init. And here we do just some example code. And I will just go ahead and fill this variant type with the string from the array list. In addition to the array list completions, let's look at enum literal completions. So here we have this variant type, which is a union enum. So it actually defines an enum with these tags. And we can see that simply by typing the single dot, we get a list of all enum tags that have been used from imports as well as the current file. Here we will just use the string tag, capture the value, and call into the standard library. We get, of course, all our nice completions. So let's just do this. And we'll add the last tag, which is empty. And the same is true for the error completions. We get a list of various errors that have been defined in various sets, but we can access them through the global error set. So here we will return the empty error that we have defined above. The next example is it's very contrived, but it's meant to just show some more complex expressions that ZLS can parse and understand perfectly well. So we have a slice type, which just wraps around a Zig slice, obviously, and some test structure type with a lot of pointers and a pointer to an array. And here we can see we are doing some nasty stuff like dereferencing and then unwrapping which would fail in this case, but we don't actually care about the runtime at this point. So just adding the dots, we get the completions we expected. So we can just keep chaining on here. And this is very fun. I'm sure everyone loves this. And of course, we get the length and pointer completions for the pointer to array type, as expected. Finally, this is one of the newest features in the last couple of days, which is payload captures for if, for, and while loops. Again, very contrived example. We just define some file list, create an optional instance. We unwrap it in an if statement, and then we just iterate over the children. And we can, again, see everything that's defined in the standard file system file type. So I just close all the files for some reason. Finally, this is the custom package support. As we saw, we can get standard library completions, but of course, people use third-party libraries. Here we are using Zig Network, which is a package you can find on masterq32 on GitHub. It is defined in a build file with the add package function, nothing fancy. We don't need to tell ZLS anything. It will just use your build.zig file and find the package. So this should work, right? We can hover, see the signature. For some reason, there is an init function. I wonder why that is. So I just go to definition. And of course, it's a Windows thing because for some reason, you have to initialize the socket. I don't know why. And of course, we can do stuff like see all the symbols, like we have a socket, we can create it, etc., etc. So this is pretty much it for the demo. So I will switch back to the presentation, and Auguste can talk to us about the future of ZLS and what we can expect soon.
Okay, that was a great demo. So firstly, there are lots of things in the future of ZLS. And for example, one of those major objectives we have is better performance on larger files. So for example, right now, if you import, say, win32.h, right, ZLS will use 8 GB of memory when you ask for completions, and that's a very big problem. And so we're aiming to fix that later with some delicious Zig hacks. Also, syntax highlighting in ZLS. So the next LSB spec 3.16 will support semantic token highlighting. And so Alex has been working on adding that. It's very exciting and very promising. And so hopefully soon that'll be supported. Also, C imports. We're waiting for the cache hash API in S2D. And we're planning on dissecting the build process in order to understand how translated C files are stored so that we can read them. Then we have missing language features. So these are smaller features that are missing. So not smaller, but just other features in general. So using namespace, for example, doesn't work at this moment. Built-in return values, like vector return values, those don't work right now. Compile time evaluation doesn't work that well, along with compile time errors. So for example, if you define a variable and then you use a variable that doesn't exist, it won't throw you any errors. So we're working on adding that. And more completion snippets, such as after a catch statement. Now, there are also some helpful Zig features in designing ZLS, right? So for example, high performance, especially when compared to TypeScript. So usually language servers are programmed in TypeScript, and they are extremely slow compared to Zig. And you can see this very well, for example, when you use the JavaScript language server compared to using the Zig language server. It's just much slower. Another helpful Zig feature is the Zig parser included in S2D. So you can see some images here of analysis.zig. It's probably one of the most important files in ZLS because it does all of the semantic analysis. And because of the Zig parser in S2D, well, this file actually works. And it also removes a lot of burden from us because we don't have to implement a Zig parser in the first place. And not only is it powerful and fast, it's also error tolerant, thanks to Vexu. So thank you so much.
Another feature I would like to talk about is the optional type support. Of course, this is very useful for pointer types as it encodes the nullability of the pointer in the type system, but it can be used with value types for great effect. Zig is very flexible with how it lets you handle null values by providing the or else operator, as well as if and while captures of nullable values. It lets you control your code very nicely. Like in this example, we can see a very simple snippet, but I think it's quite nice. We can just unpack the optional type and handle the null value in an arbitrary block without having to nest a lot of if statements and create like 7 levels of nesting for no reason. And finally, I would like to talk a bit about the allocators in Zig. Of course, in most system languages, allocating and deallocating memory is manual, so it's explicit. However, their standard libraries make the assumption or pretend that there is some global allocator without a state that can be called at any time from any thread. One of the nice things about Zig is that we completely discard this notion. The allocator interface is defined in the standard library, and allocators are explicitly passed around in functions that will allocate memory, as well as types that may do so. This is very nice. You can just look at a function signature and tell right away what it's going to do. It also allows us to create more composable allocators. Since everyone is using the same interface, we can do new allocators that wrap around third-party allocators or allocators that are defined in the standard library. Here we have a very simple example of a debug allocator in the ZLS codebase. It just collects some information at runtime about allocations and reallocations and etc. And provides some formatting help to print this information. Of course, you can do a lot of things like capturing stack traces for every allocation and releasing them on matching the allocations, so you can get exact stack traces for your memory leaks, or creating more efficient allocators. Basically, anything you want to do with some standard interface that basically all Zig code will support. So this is the end of our presentation. I would just like to thank everyone that has used ZLS and has reported bugs as well as requested features, and of course everyone that has contributed to the project, and yes, they have my very warm thanks.
Yeah, and especially Vexu, because he really went beyond, and he improved the standard library specifically for ZLS to add important features, and that's really amazing. So thank you so much for that.
Okay, thank you guys. That was awesome. So let's switch back to the Q&A. Just give me a second so I can put back your screen share in the center. Okay. Okay, so let's start with a couple of rounds of questions for both of you, and let's start. For the order, let's start with Alex, then we'll go to Auguste. So, first question is, of course, how did you discover Zig?
Right. So, like a lot of people, I think I saw it on Reddit first. I'm not sure, but I believe so. A couple of years ago. And I looked into it, and immediately I saw all the compile time evaluation stuff, and that's basically how I got involved. Like right away, I thought this is very cool, and it fitted what I thought most languages should do instead of using macros and other languages, etc.
Auguste?
So I discovered Zig actually last year around December because I was getting very bored of JavaScript and I wanted to try something new. And when I originally saw it, I was like, okay, this is a cool language, but it's very experimental. So I'm not quite sure I'm going to use it yet. But when quarantine started, I decided to use it because I had a lot of free time, and I learned Zig, and I fell in love with it. It's just a fantastic language.
Okay, awesome. And how did you both end up working on the same project? And not only that, right? You also created a group on an organization on GitHub called Zig Libs, right? So what's your story?
No, Zig Tools actually.
Oh, sorry, Zig Tools.
XQ created Zig Libs, yeah.
Oh, sorry. So how did you end up working together?
Right, so I'll take this, I guess, first. So I think I saw Auguste asking for help in Discord. I'm pretty sure that was it. So I just checked out the project since I needed some tool to work better with VS Code, and I saw that it had potential and it had some stuff partially implemented. So I thought I would just help him and get a tool for all the community. So, which I think is very helpful.
Auguste, anything to add to that?
So yeah, that was kind of it. I was asking for other contributors because it's a very big project. And yeah, he just found the repo and he started working on it, and so we split up the features. And yeah, it's been working great ever since then. So.
Okay, I see. So let me see if there's any question from the public. I think you have a lot of users already because I think I saw all the streams, all the Zig streams that I've seen. People using VS Code for sure have been using your language server.
Actually, Michael LaRouche, Michel, last presentation is actually using it, I think.
Yeah.
So yeah.
Let's see. I think you guys have people know already way too much about your ZLS project, so I don't see any question. But
no juicy questions.
Yeah, no questions. Well, I can tell you that the presentation was really clear. So yeah, congrats. You did a very good job also juggling it back and forth between you two. So yeah.
Cool.
Well, okay, so there are a couple of questions. So first of all, is it easy for a Vimmer to pick up Kakaune? Maybe not for you, but maybe you can also answer that question.
I haven't really used Vim, I'm not so sure. I've tried some Kakuna just to test around the LSP on the language server on Linux. But I think they are pretty similar, but I'm not sure, so I'll just leave it at that.
Is the ZLS, is it published on VS Code?
Yes, it is. It's a published extension now.
Okay, cool. Michael LaRouche asks, how can I get VS Code to show the Zig icon for Zig files?
This is another extension. I think it's called VS Code icons.
Do you want me to switch back to the view where you're sharing the screen? Okay.
Let me just, yes, this is this extension, VS Code icons. When I installed it, Zig support was not in the published extension. I just downloaded it from GitHub and installed it from there. But I'm sure if you get this version, it should have the icons.
Yeah, when I downloaded it, I actually chose it because it had Zig support for icons. So, yeah.
Okay. Well, is there anything else that you guys want to say?
Yes, for me, I want to thank you so much, Loris. It's a great event. Zig SHOWTIME is awesome. So thank you so much.
Yes, I'll echo that.
Okay. Alex, are you sure this would be a great opportunity for you to do some advertisement for yourself?
No, it's okay.
It's
don't
okay?
worry. Yeah.
If you want, I can do it for you.
No, it's
No?
okay.
Okay.
Don't worry.
Okay,
Thanks,
then.
though. Thanks.
Well, thank you both then. That was awesome.
Cool.
Hash really quickly.
Oh, yeah, sorry. Yeah,
Yes.
go ahead.
If you like ZLS, give us a star and follow us on GitHub. So I guess that's Super August and Alex Mask. Follow us and give us some stars. Yeah.
Great
yeah.
move. Great move. Thank you, guys.
Right.
Yeah. Thank you.
Thanks.